Welcome to Kotlin Crash Course, and I will be your instructor for this course. So, what we learn in this course? First, we will talk about the Kotlin programming language and what it can be used for, and so on. And next, we will talk about the basic syntax. And in this section, we will cover variables, ranges, control flow, and functions. Next, we will talk about classes, objects, interfaces, and so on. I'll talk about constructors and all about inheritance. And then we will talk about collections and the different types of collections available in Kotlin. Then we'll talk about Lambda expressions and what are high order functions and why are they useful. Finally, we will wrap up and talk about the 5 scope functions available in Kotlin and give examples for each. So, what is Kotlin? Kotlin is a statically typed programming language and has been developed by JetBrains in 2011. And of course, you can use Kotlin for either server side or client side, and then you can use it for web and mobile too. And it is the first class language on Android. So if you want to do Android development, you should learn Kotlin. So what are the tools needed for this course? Thankfully, we will need just one tool, which is Intellij IDEA. So enough with the theory. Let's go ahead and download the tool. So in Google, let's go ahead and search for download Intellij IDEA and click the first link, which is JetBrains. And so we have two editions. We have the Ultimate editions and we have the Community edition. Let's go ahead and download the Community edition. This is the latest release and the download should start shortly. So after the download complete, we can go ahead and go to our downloads and start installing. Let's go ahead and click next. And this is the download installation path. I'm going to go ahead and click next too. And you can create a desktop icon if you want. Let's go ahead and click next again, next, and install. So it will start installing. So finally, it's installed. Let's go ahead and check run Intellij IDEA Community Edition and click finish. You can choose don't import settings, click OK. So now let's go ahead and create a new project and you can name it Kotlin Crash Course. And for the language, go ahead and choose Kotlin and make sure add sample code is checked. Let's go ahead and create it. Once the project is set up, you should see that we have this src package, and inside it we have main package and finally Kotlin package with just one file, which is main.kt, and you can run the code using this arrow function right here or even from the top also, or use the shortcut shift and F10. So let's go ahead and remove some of these and let's remove those arguments too, so we can do the classic hello world app. Let's go ahead and run main.kt and it will simply print this text, which is hello world. And as you can see, hello world gets printed out, and now we are ready to start learning. So let's start talking about the basic syntax of Kotlin. And let's begin with the variables. And in Kotlin, we can start declaring a variable with a keyword. And you may or may not need to specify the variable type after the name because Kotlin lets you omit the variable type. So let's create a variable name and assign it the value. So I'm gonna go and type val name and I'm gonna give it the value John Doe. And since we give it a string value, this is string value, now Kotlin knows that this is a string, and you can hover over it. And as you can see, Kotlin knows now it's a string variable. Otherwise, we can tell Kotlin explicitly that this is string by using the colon operator and the type string. So let's go ahead and create another variable here. I'm going to call it name string, and I'm going to explicitly say this is a string variable by using the colon operator and then the type, which is a string. In this case, I'm going to assign it a value right here, John Doe. So now we told Kotlin explicitly that this is a string. We can also create another variable. I'm going to call it age. I'm going to give it the value 26. And since we give it an integer value, Kotlin knows that this is an integer variable. And we can also, of course, specify the type explicitly using the colon operator. And in this case, it's an integer. So I'm going to type integer and give it a value. So what if the variable doesn't have an initializer? You will need to specify the type explicitly. So if I define this variable, for example, GPA, and I didn't initialize it, the compiler will highlight it as an error. And if the variable doesn't have an initializer, we need to specify this type explicitly, and then we can later give it a value like so. So if the variable doesn't have an initializer, you need to specify its type explicitly. So Kotlin has two keywords to declare variables. We have val, which we use it right here, and it is from the word value, and it's create an immutable variable, and val cannot be reassigned. So let me just get rid of this. So if I try to reinitialize this age right here, like 20, the compiler won't let me do that because val cannot be reassigned after it's initialized like a final variable in Java. If you take the cursor and look like here, you can see that the error says that the val cannot be reassigned. So another keyword we have is var, and this is derived from the word variable, and it's create an immutable value, and this value can be reassigned after the initialization. So let's go ahead and create var GPA right here, and we can give it the value 4. Since this a var, I can reassign it right here and give it the value 4, for example, and this works just fine. So as a best practice, declare all your variables in Kotlin with the val keyword and change it to var only if necessary. So let's talk about another important thing is that formatting the string with the string templates. And sometimes you may want to inject a variable value inside the string. And string templates are a string literals that contain embedded expression. So if I have this val name, define it as John, and I can define another variable here, call it greeting, and I can give it the value hello, and then use a dollar sign and concatenate or inject the value of the name using the dollar sign here, and then the name of the variable. And this is what is called the string templates, and I can easily print the greeting right here. Let's go ahead and run it. and we should see hello John printed. As you can see, we have hello John printed. So next thing, let's talk about ranges. And a range is essentially just an interval between two values, usually numbers. We have the start of the range and we have the end of a range. We can write it using the double dot operator. So if I want to define a range from 1 to 10, I can do it like this. 1 to 10. I will store the value inside this val, and then I will do 1 to 10. And this way we created a range from 1 to 10. And you can check a number inside specific range using the in operator. We will talk about the if statements and control flow in the future. So this is the if statement. I can check if, for example, if 5 is in this range from 1 to 10, for example. And of course, this is always true. So the compiler highlighted this condition. Another important thing that ranges in Kotlin are closed or exclusive, meaning that the second value, like 10 here, is included in the range. If you want to skip some numbers in this range, you can use the step function. So let's go ahead and create another range here with a step. Let's call it range with step, and I will define the range as usual from 1 to 20, but I want the step to be 2. So it will create a range from 1 to 20, but the step will be 2. You can also use down to function to create a range with a step of -1. So for example, I will create a range from 4 to 1, 4 down to 1. So now we have a range with a -1 step from 4 to 1. So let's go ahead and talk about control flow. And we'll start this section with talking about the if expression. And Kotlin, by the way, doesn't have any ternary operator like in Java, for example. That is because the if statement works as an expression by itself. So let's go ahead and have a small example right here. So if I define the variable, call it age, and give it the value 20. I want to check if this age is greater than 30. I can say if age greater than 30, and then use these curly braces to execute this block if the condition is true. So I'm gonna go ahead and print that age is greater than 30, and of course this will be always false right here. So we can simply just change this to 10 and change this to 10 too. So if I run the application right now, it should print that the age is greater than 10. And as you can see, it's printed. That is because this condition has been satisfied, and this is just the traditional use of the if statement. We can also use an else clause right here, and we can print another message, age is less than 10. And of course, we need to change this value so this else clause can be executed. Let's go ahead and make it 5. Let's go ahead and run this application, and we should see that age is less than 10 printed. As you can see, we have it printed right here. If statements acts as an expression in Kotlin, so the last statement inside an if block or inside an else block can be returned and assign it to a variable. I can create, for example, instead of printing, I will just return a message. So I want to return this message or this value. You can return an integer if you want. and store it inside a variable. I'm going to call it message. So the message will equal to this if this condition is satisfied. And as you can notice that we didn't need to write a return statement right here, because if in Kotlin acts as an expression and it will assign the message to the last value here or inside the else clause. We can print the message just to be sure. Message. Let's go ahead and run it, and we should see that the age is less than 10 printed. That is because the message is equal to age is less than 10. So let's talk about when expression. And the when expression in Kotlin replaces the switch statement like in Java. In its simplest form, it will look like this. So I have this age variable and I want to test it against a lot of conditions. Use the when statement like so. I'm going to say when. I'm going to pass the variable I want to test its value. This is age. I'm going to use a curly braces. I can check if the age is equal to 1. I can print a specific message. Note this arrow. So let's go ahead and print age is 1. We can also check if it's equal to 2. We can print age is 2. We can check also if it's equal to 5, for example. And we can print that the age is 5. Also, you can add an else block right here. And if you want to execute more than one statement, you can use the curly braces to execute more than one statement, and we can print age is out of range. So if I run this, it will check the age against 1. If it is satisfied, it will print this value, else it will print this value, else it will print this that age is 5, and if not, it will print that age is out of range. So let's go ahead and run the application right now, and it should print that the age is 5. So what if I change it to 15? If I change it to 15, the else block will be executed. Let's go ahead and run it again, and we should see that the age is out of range gets printed. That is because it's tested the first 3 condition and we didn't find any match, and it will execute the else block right here. And those are called branches. When can also be used as the replacement for an if-else chain. If there is no argument supplied, the branch conditions are simply Boolean expressions. Let's go ahead and test. I'm not gonna pass any value. Right now, I will use the curly braces directly and then check if the, for example, age is equal to 5. This is a Boolean expression. And in this case, I want to print that the age is 5. I can have another branch that, for example, age less than 10. And I can print that the age is less than 10. So if there is no argument supplied, the branch conditions are simply just Boolean expression, and of course this line will be false and this line will be false too. And sometimes you may need to add an else statement right here, and then you can say that age is out of range. So let's go ahead and run it. It will try to execute this and execute this, and as you can see that age is greater than 10, so we have this message that the age is less than 10 be executed. We can also check that if a value inside a specific range, and we have talked about ranges a while ago, so we can check if the age inside a specific range using the in keyword. So if the age from 10 to 15, it will print a specific thing. You can use the curly braces right here too. And we can print that age is between 10 and 15. And you can also use not in. You can also use not in for the ranges. For example, from 10 to 20. And you can print another message right here that the age is not between 10 and 20. So this is how you can check if a number inside a specific range. When a statement is widely used with sealed classes to enforce that branches possibilities are being covered. So let's go ahead and talk about for loop. And unlike Java and other language, there is no traditional for loop in Kotlin. For loop is used to iterate through ranges, arrays, and maps, and so on. So for example, I can iterate like so for I in 1 to 5, and I can print the I. We'll use print ln right here because we want to print each value in a separate line. I'm going to print the I. Let's go ahead and run it. As you can see, it's printed the values from 1 to 5 because we have the range from 1 to 5. And of course, this range could be also a map or an array and so on. We can also iterate over the numbers with a step. So for example, I can create a step right here from 1 to 10 and the step to be 2. So this way we can have the numbers from 1 to 10 but with a step 2. Let's go ahead and run it to see the result. We should see from 1, 3, 5 and so on. So 1, 3, 5, 7 and 9. Also Kotlin have the while loop and the do while loop, and the condition doesn't differ from the loops in Java. You can have a condition if the age, for example, is greater than 10, and of course I need to define the age right here. And if this condition is true, it will keep executing this block unless you break out of it. And also we have the do while loop. And of course, when you use do while loop, you will be certain that this block will be executed at least one, because we check the condition of the age that is greater than 10 at last. So we execute first and then we check the condition. So let's talk about functions. And functions are just a block of code organized and reusable that can be used to perform a single related action. And function declaration in Kotlin is start with the word fun. And as you can notice that the function main start with the fun keyword. And after the fun keyword, you will have the name of the function followed by parameter list in this parentheses. Let's go ahead and see an example. Here we are declaring a function called sum that have two parameters, a and b, and it will return the sum of those two parameters. So let's go ahead and create a function with fun keyword and let's call it sum. And after that, we need these curly braces and we need to define the parameters, which is a and b. So in Kotlin, you define the name first, followed by the type of the parameter, which is an integer right here. And then we will use a comma to separate it from the p, which is also an integer. And finally, you will specify, after a colon, you will specify the return type, if any, for that specific function. It will return an integer, which is the sum. It will execute this block of code inside this curly braces. And we want to return the sum of those two numbers. So we'll simply return a plus p. So let's go ahead and call this function from our main function, define a variable to store the result. Let's go ahead and call it result, and it will equal to sum of 3 and 4, and we can later print the result. So we should get 7 as a result. Let's go ahead and run it, and as you can see, we have the output as 7. We can simplify this function even further. Because the body consists of a single expression, we just returning the a plus b expression right here. You can use that expression as the entire body of the function, and we don't need the curly braces, return type, and the return statement. So I can simply replace this with an equal sign, remove the curly braces, and this is 2, and it will equal to a plus p. So if a function is written with its body in curly braces, we can say that is the block body of the function. And if it's only return an expression like so, we call it an expression body. You don't always need to specify a return type for a function that returns nothing. You can simply omit it. Let's go ahead and create another function and call it print greeting, and you can simply print hello there. And as you can see, we didn't need it to specify any return type. We can call it from here print greeting. Let's go ahead and run. We should see 7 and also hello there printed. We should use print ln right here. As you can see, we have 7 and then hello there. So let's go ahead and see how you can create classes in Kotlin. To keep things organized, we're going to create a new file from here. Right click and go ahead and create new Kotlin file or class, and you can select class and then type in the name of the class. I will call it a student, and as you can see, we have this class. Students and classes in Kotlin are declared using the class keyword, and then the name of the class, and finally we have curly braces. And Kotlin have two types of constructors. We have a primary constructor and a secondary constructor. A class in Kotlin have a primary constructor and can have one or more secondary constructor. The primary constructor is a part of the class header itself. This is the class header, and we will see in a minute how you can create a primary constructor for it, and just it goes just after the class name, and the primary constructor cannot contain any code. Let's go ahead and create a primary constructor for this class, and just after the class name we can use the word constructor like so, and then inside it we can define an attribute, for example first name, and of course the type is a string. If the primary constructor doesn't have any annotations or visibility modifiers, you can omit the constructor keyword. So we can omit this keyword and still the class will work as expected. If you want to write an initialization code for a class, so if I type init, and now inside this init block, the code will run as soon as a new instance of this class is created. I can print something. This is an initializer block. And of course, you can have multiple initializer block. We can have another one right here, and we can print this is the second block. And initializers block are executed in the same order as they appear in the class body. So this will be executed first and this will be executed second. So when I create an instance of this student class, we should see this line printed first and this line printed second. Let's have an ln right here. So the print will be in a separate line. Let's get back to the main class, and you can easily create a student object like so. You can use the constructor and pass in the name. So let's go ahead and pass John. So when we create this specific instance, the initializers block will run and it will execute it sequentially. It will execute the first initializer block and then the second, and we should see this statement executed first and then this statement. Let's go ahead and run. As you can see, we have this is an initializer block, and we also have this is a second block because those initializer blocks are executed in order. For declaring properties and initializing them from the primary constructor, Kotlin has a nice syntax, and a property in a class can be either var or val. So we can actually delete this for now, and we can make this as val. We can also have another one, a last name, for example, of type string. So now we have the first name and the last name as properties, and those two properties will get initialized as soon as a new instance is created, and it will be passed using the constructor. Let's talk about secondary constructors. So let's go ahead and create a new class for that. New Kotlin file class and call it person. So to create that constructor, use the word constructor right here. And of course, you can pass any argument you want. For example, if I have the name right here of type string, okay, and I initialize it as an empty string, I can pass a value right here for that field of type string 2, and then I can initialize the name value. And don't forget to use the word this. So this will point to the class members or the class attributes when you have duplicated names. So we have name here and we have name here, and we need to initialize this with the value that is coming from this constructor. And of course, a class can have functions. So I can create a function inside this class, and I can call it print the name like so, and it will just print the name, pass it to the constructor. So I'm going to print name. To call this method, it's very straightforward. You can use an instance of a class. Let's go ahead to the main and let's define person instance and person. So now we need to pass in the name like so, and we can invoke this function easily using the class instance and then dot and then calling the function print the name. So now we should see that the name gets printed out. Let's go ahead and run it. So now as you can see, we have John Doe printed. Let's talk about inheritance. And inheritance is one of the key features of any object-oriented programming, and it allows users to create a new class, a derived class, from an existing base class. And by default, classes in Kotlin are final, and that means you cannot inherit from those classes unless you mark it using the open keyword. So let's go ahead and try. I have person right here, and if I want to create another class and derive from this class, I want to extend this class fireman, for example. And to extend the class, you will use the colon operator and then the name of the class followed by curly braces. As you can see, we have an error right here. And if we hover over it, we see that the type is final and you cannot inherit from this person class unless you mark it as open. Let's go ahead to the person class and make it open and prefix it with the word open. And as you can see, we need, of course, to pass the name like so. So So I just pass the name right here. And we can add properties, of course, for the fireman. And let's see, I'd add a method like here, firefighting. And this is just a new property that the fireman can do. And class methods are final by default, and you cannot override those methods in a subclass unless you mark them open. If I want to override this method, I cannot do that unless I mark it as open, and then I can override it right here, print the name, and as you can see, we have this method right here. And of course, when you override a method, you need to add in the override keyword just before the function. It's worth mentioning that Kotlin does not support inheritance from multiple classes. Multiple inheritance is achieved using interfaces. So you cannot extend multiple classes, but you can do that with multiple interfaces. Let's talk about a very important concept, which is the data class. When you create a class, you usually create this class to hold some data. And in Java, we used to write a lot of boilerplate code, such as equal methods, hash code, setters and getters, dot to string method, and so on. And although Java IDEs can automate this generation of those methods, the boilerplate code is still present in your code base, and also you have to maintain it. In Kotlin compiler, it takes a step further, and it also generates these methods behind the scenes using what is called the data class. Let's go ahead and see an example. Right click, let's go ahead and create a new class, and it's a normal class as a start. And in order to convert it into a data class, you will add the word data class before that, and we need to use curly braces, and inside it you can define properties like the name, also the age. Now Kotlin will take care of creating setters and getters and equal message for those values. Of course, in a data class, it is required to have the primary constructor to have at least one parameter. So if I removed those, as you can see, we have an error, right? So, and we need to define at least one property, and all the properties should be val or var, and data classes cannot be open, sealed, or abstract. We can create some instance using this user class. Let's go to main right here, and let's create a new user like so. And we can create the name, also the age, and you can directly access those properties using the dot operator. So we have the age like so. We also have the name like so. We can print it. We can print the user dot age and then print user dot name. And if we run the application, we should see 25 printed and then the name John Doe. So we have 25 and the name John Doe. So we don't have setters and getters unlike Java. We can access the properties directly using the dot operator. And of course, if you try to reassign this value, for example, I want to change the age like so to make it 30. You cannot do that because the age is val and you need to change it to var in order to do that. Let's talk about sealed classes. A sealed class will restrict the possibility of creating a subclass, and we use the sealed class when a value can have one of the values, one of the types from a very limited set but cannot have any other value. For example, an API call response can only have two states, either success or failure, and this is a suitable situation to create a sealed class for it. Let's go ahead and create a new sealed class. We're going to call it API response, and this is a normal class. In order to convert it into sealed class, prefix it with the word sealed. And inside this seal class, we can have childs. We can have nested child. So for example, I can have a data class right here, and I can call it success. And the success, for example, will have some data type string, for example, and it should extend the API response. We can create another nested child in it, failure, and we can have, for example, an exception, and it should extend API response too. So those are called direct subclasses or children. A seal class can have subclasses, but all of them must be declared in the same file, and a seal class is an abstract by itself and cannot be instantiated directly. So I cannot create an instance of the API response, but I can for the success and failure. So seal classes can be used effectively with the when statement. Let's go ahead and try that in the main function. So for example, if we have a function that will do an API call and it will return a response right here. So let's call it get response, and it will return an API response. And for simplicity, we will return directly API response dot success, and of course we need to pass some data right here. So if we have a response that is coming from the API and we need to check this response, we can use when statement to check the response, and we can check if the response is success. We can execute some code right here. Call API call success. Else we can execute another one if it's a failure, and we can print API call failed. So the when statement will check the response. If it is a success, we can print this message, or we will print the API call is failed. And even if someone added a new child to the API response seal class and forget to add it to the when statement right here, the compiler can give an error if the branch is not covered. Let's go ahead and try to add another one here, and let's name it, for example, data class time, and it will extend the API response. And of course, we need to define a value because data class required at least one parameter in the constructor, val error string. So if we get back to the main, we will notice that we have highlight an error right here. And as you can see, non-executive when statement on a seal class, and we need to add an else branch, or we can add a new branch for the new value, which is API response dot timeout, and then we can execute another line right here. API call timeout. So let's go ahead and run and see the result. And we should see, of course, that the API call is success because we explicitly return it, but you can use this to check the API call from a server and then execute a specific line. And as you can see, we have API call success. Let's talk about Enum classes. And in Kotlin, as in many programming language, an enum is its own specified type, and we can indicate that something has a number of possible values. So for example, we can create an enum for the color. Let's go ahead and create a new Kotlin file or class. We can of course select an enum class from here, and let's call it color. Now, as you can see, an enum is just a class, prefix it with the with the keyword enum, and it can have multiple values, for example, red, orange, yellow, green, and so on. So just like in Java, and enums aren't a list of values. You can declare properties and methods on enum classes. And if you want to add a properties, you need to add a semicolon to the last value of the enum class. So if I try to add a function like so, print the color, for example, you have to add a semicolon to the last value like so, and then we closed the values here, and you can then add properties and functions to the enum class. An enum class uses the same constructors properly declaration syntax we saw earlier in the regular classes. So we can use when statement for those as well. Let's get back to the main and let's define a function right here, and let's call it get color, and we need to return a specific color, and of course you have to define the color right here. This is an attribute, and let's go ahead and return. And as you can see, when I start typing, I will see the suggestions and I can select, for example, orange. So of course we can check this value also using a when statement. So let's go ahead and create a color, and it will receive the value from get color, and then you can use this value with when statement to check. And of course you can let the compiler add the branches for you. You can hover over the when statement and you can click more actions and then select add remaining branches, and it will write out the branches for you, and then you can just execute the colors, the code, and we can, for example, print red. Here we can print orange. So let's go ahead and run the code, and we should see that the word orange is printed. As you can see, we have the word orange printed. Another important thing is objects. First, let's talk about singleton because it will help us understand what are objects in Kotlin. A singleton is an object-oriented pattern where a class can have only one instance, in other words, an object. So for example, you are working on an application that have some database in the backend and you want to create a connection to access this database while you reusing the same connection for all clients. For this, you can create connections through a singleton class so that every client will get the same connection. And in Kotlin provides an easy way to create a singleton using the object declaration feature. So let's go ahead and see an example. Let's go ahead and create a new class right here and call it singleton example. And if you scroll down here, you can select object. So it is not a class, it's an object, and this is an easy way to create a singleton. And an object declaration can contain properties, methods, and so on. So I can create a property, call it name, and I can also have a function, print the name, and we can use it to print the name. So just like classes, we can declare properties and methods inside an object, but they are not allowed to have constructors, which makes sense. And the object keyword can also use to create an anonymous classes, and you will see this word a lot in Android development. For example, when you have an on-click listener on a button, you will use it, or you want to have some inner class for a callback, you will usually use an object for that. And to access the properties, the method, inside an object. You cannot create an instance, of course, but you can access those properties and methods directly using the class name. So I can say print singleton example dot name, or I can call the method directly singleton example print the name. So it usually works like a static class in Java. Let's talk about companion object. And if you need a function or a property to be tied to a class rather than an instance, it's similar to static methods in Java, of course. You can declare it inside a companion object. So let's see an example. Let's go ahead and create a new Kotlin class. And let's call it my class. Make sure class is selected right here. And inside this class and create a companion object. And inside it, you can define, for example, any public property you want to access from other classes. So let's create a tag, my class. And now we can easily access this property, my class, anywhere without creating an object of this class. So I can print it, for example. Let's go ahead and print my class dot tag. And it will work just fine, and it will print my class. And the final thing we want to talk about is interfaces. And interfaces in Kotlin can contain declaration of abstract methods and as well as implementation, which makes them different from abstract classes is that interfaces can store a state. So unlike abstract classes, we can store a state inside the interfaces. So let's go ahead and declare a new interface, new Kotlin file or class, and call it my interface, and make sure the interface is selected. As you can see, interfaces are created using the keyword interface, and you can of course have a function like so, a function without a body, and we can have another function with a body. So creating a body is optional. You can write the implementation or just define the function header. A class or an object can implement one or more interfaces. So if I have a class right here called child, it can implement this interface using the colon operator and then the name of the interface. So as soon I implemented, as you can see, we have an error right here, and it says that this class is not abstract. It cannot implement abstract members, and we need to implement those. And let's go ahead and click OK. So we need to override this method because this method doesn't have an implementation inside an interface, and you need to override it. You can also override foo if you want. You can override this function too if you want to change its implementation according to your needs. So this is, of course, is an abstract property method. You can also define an abstract property, for example, prop, and it is of type integer, and any class that inherits from this interface will have to implement this property. So let's go ahead and create it right here, and we need to implement the members. Let's go ahead and select properties and click OK. And as you can see, we didn't only override the methods, but we also overrided the properties, and we can set a value for it like 22 for this, and this is just a getter for this property. But you can also get rid of this and just write the implementation directly and assign it a value. And of course, a class can inherit multiple interfaces. So we have another interface here, interface, second interface, we can extend it right here and just call second interface. So now we have multiple inheritance without classes, but instead using interfaces. So let's talk about nullable types and non-nullable types. And in Kotlin, we distinct between a nullable type. In other words, it could hold a null value too, or non-nullable types, and those cannot hold any null value. And the idea here is to avoid one of the most common things in other programming languages like Java. We have a null pointer exception that will be thrown if you try to access a property or call a method on a null reference. So to avoid that, Kotlin introduced nullable types because you can check for null before executing any code. So let's see an example. I can create name, for example, of type string and assign it a value John Doe. And this type right here, it's a regular initialization and it is not null by default. So if you try to assign or reassign this name, if I try to reassign it a null reference like so, the compiler will not let me, and this is a compilation error. And as you can see, it will say that null cannot be a value of a non-null type string. So if you want this variable to hold a nullable value, you can explicitly do that by adding a question mark after the variable type. So this way I created a nullable variable. In other words, it can hold a reference to null, and of course you need to check for nullability before executing any method. So if I try to execute, for example, I want to print name.length like so, it will show an error and it will ask you that you need to use the safe call. And this is one of the ways you can check for null conditions in Kotlin using the safe call operator, and you will just add a question mark before invoking the property or the method. So this time you can check for null. So if the name is null, it will just print null, else it will print the length of that variable. So there is no error will be thrown and the app will not crash. And this is called the safe call operator because it will let you safely execute calls in an object or any variables. The last thing we want to talk about in this topic is the not null assertion operator, which is the double exclamation mark like so. And this operator is used to force tell the compiler or the IDE that you are 100% sure that this value will not hold a null. So for example, if I 100 sure that this name is not null, it is nullable, but I am sure it is not null right now, I can explicitly do that and add not null assertion operator like so, and I can execute that. Of course, you need to remove this null assignment first, and then you can access it like any normal value, but it's not recommended to use this operator. However, sometimes you are 100% certain that this value is not null, so you can proceed with your code. So let's talk about collections in Kotlin. A collection usually contains a number of objects of the same value, and objects are in collections called elements. So each object is called an element or an item. For example, all the students in a department can form a collection, and we can use this collection later, of course, to calculate their average age or do any calculation we want. There are four types of collections in Kotlin. We have number one, array, number two, list, number three, set, and number four, map. So let's talk about arrays. And arrays are very common in programming languages, and Kotlin is not an exception. And each value in an array is indexed by a position, and the positions are usually started with zero index. So arrays in Kotlin are zero indexed. That means the first element have the position 0. So let's go ahead and create an array of any type. You can create an array of numbers, for example. You can create an array of any type you want. I'm going to create it of numbers and use the function array of, and then pass in the numbers you want, 2, 3, 5, 6, and 10. So now I have an array of integers. So to print out the values of an array, we can iterate over those values using for each loop. Let's go ahead and access array of numbers and then call for each loop and select the first option with the lambda expression, and it will give us a reference to the number. As you can see, we have an it right here, and we can rename the value, and we can rename it to a number like so, and then we can easily print ln that number. Let's go ahead and run, and we should print the values in each line. As you can see, we have the values printed out like here. So another way to iterate over those arrays, we can use normal for loops. So we can use a for loop. So we can for number. So for each number, I'm calling my counter or my current element number. So for each number inside or in the array of numbers, I want to execute a specific line, and this value will hold the number 2, and the next iteration for the row, it will hold number 3, and then number 5, 6, and finally 10. And I can print it, print ln like so, and I can print the number, and it should give us the same result. We should have the numbers printed out in each line separately. So in order to access numbers or elements inside an array, we can use square brackets. So to get the first square brackets, like the first value or the first number, we can use the array of numbers and then use the square brackets and pass in the 0, which is, in this case, it will be number 2. And let's go ahead and print it. First value, and we should see 2 printed out. So in order to change a number on a certain index, we can use a similar syntax. So if I want to change this number, array numbers. So if I want to change the first value, which is 2 in this case, I can change it and make it, for example, 100. And then I can print the first value inside that array of 0, and we should get 100. So now we change it, the element at position 0, and assign it to 100. So now we have 100. So if you want to iterate over this array with indexes, we can use for each indexed. So we can access the array of numbers, and instead of using for each, we can use for each indexed. Let's go ahead and select the last one, and it will give us the index and then the number. It's an I right here. We can change the name to make it number, and then we can print ln the number. You can use the $sign and then access the value of any variable is at the index. So now we should see that 2 is as index 0 index and 3 is at the 1 index and so on. So let's go ahead and run it, and we should see the numbers printed out with each index. So now the 2 is the first index, 3 at the 1st index. So let's talk about lists. So lists are a dynamic version of arrays. In terms of memory, dynamic means that you can allocate each element in any free memory slot. List collections can be mutable and immutable. So let's talk about immutable list. In other words, read only. And it's very easy to create a list in Kotlin. So let's go ahead and create it. So we have list, and we can use the function list of and then pass in the numbers like 1, 3, 5, 7, and so on. So now we have a list. We can print this list easily. Let's go ahead and print it directly. So now we have this list printed out, but we cannot modify its element after it's created because it's a mutable list. So if you want to access, for example, if I want to set the first element, I want to change the first element, which is 1, I want to change it to 10. You cannot do that, and as you can see, there is no set methods provided because this is immutable list. In other words, it's read only, it's constant. After created, you cannot change its content. Next, let's talk about mutable lists. A mutable list has the ability to add, remove, and insert element at certain indexes. And we can easily create a mutable list, and we create it using the function mutable list of, and then you can pass in the values 2, 3, 5, 6, and so on. So now we have a mutable list, and we can change its content. For example, if I want to change the first value, which is 2, I can change it easily, access it using the square brackets, accessing the first element, and change its value to 100, and then I can print that element to check. Let's go ahead and print the first element. So now, as you can see, we have 100 printed. Another thing you can do in a mutable list, you can insert an element in a specific index. So for example, if I want to add an element, mutable list, I can add an element at a specific index. Let's say at index 3, which is this right here, the last element. I want the element to be 500, for example. Let's go ahead and print the element we just added, which has the index 3, and we should see, instead of 6, we should see 500 printed. Just to be clear here, we didn't remove the last element, but the last element will be shifted. So if I printed the last element, which will be the 4th index, because we added an additional number right here, it will print number 6, which is the last element in this array. And as you can see, we have 6. So in this operation, we just added an element in a specific index, and the other element will shift to the right of the array. You can also remove an element. So for example, if I want to remove this element, it is not an index, I will pass the element itself, which is 5. I want to remove the 5 element from the list, and then I can print it, mutable list of list, and we should see that the array should contain 2, 3, and 6 only, And as you can see, it contains 2, 3, and 6 because we removed the element 5. You can also remove a specific index using remove at, and then you will pass the index. If I passed 0, we should now remove the element 2. So let's go ahead and print it. And as you can see, we have 3, 5, and 6 only because we removed the element at index 0, which is 2 in this case. And just like arrays, you can iterate over those elements. So let's go ahead and iterate over this mutable list using for each loop with the lambda. And then you can rename the each element into just an element. Now we can print ln this element. As you can see, we have 2, 3, 5, and 6 printed. Another useful method we can use on lists are map. And using the map function, you can create a new list from the existing link. So for example, if you want to square each element in this list, I want to square it. Store, of course, the squared list. And it will equal to my list dot map, and I can rename it to an element like so. And now each element will be mapped to element multiplied by itself. So each element should be mapped by element squared. So the 2 should be 4, the 3 should be 9. So let's go ahead and print that. Of course, the map function right here, it will return a new list. So now we store it inside this reference squared list, and then we can print it squared list. And now we should see our squared list. As you can see, we have 4, 9, 25, and 36. So let's talk about sets. A set is a collection of elements where each of the elements is unique and there is no duplicates. So they are useful when you need to filter out duplicates. For example, you may use a set when storing IDs or users. Let's go ahead and create a set. So I'm going to create a set right here. I'm going to call it var user IDs to store a list of users ID. And I can use the method set of and then can pass in the elements 1, 2, 3, 4, and 1 again. So let's go ahead and print the set of user IDs. Now we have a duplicate element. As you can see, we have 1 duplicate, but when you print the set, you will notice that it doesn't print any duplicate elements. And you can also use and create a mutable set by using mutable set of also, just like we did with a list or a map. So now I created a mutable set. You can remove it easily by using the same technique. For example, I have the user IDs, and then I can remove a specific element, for example 3, and then you can print these user IDs. Let's go ahead and run it, and now we should see 1, 2, 4. Now we have 1, 2, 4 because I removed the element 3 and element 1 is duplicated. Finally, let's talk about maps. So maps are a collection of a key value pair. Maps are extremely useful when you are trying to tie one value to a key like an ID or string identifier. So to create a map, you can use map of. Let's go ahead and call our map HTTP headers, for example. And basically, using map of, you can create an element of key value pair. So each element have a key and have a value. So now, for example, if I have authorization, I can map it to my API key because this is an HTTP header map. Also, I can have, for example, content type and map it using to as an application /JSON. Finally, for example, the user locale and map it, for example, US. So this is the key and this is the value. So now we created a map of key value pairs, and of course the keys and values can be of any type. In this case, we have, if we hover over it, we have a key of a map of type string. So string as the key and also string as a value. You can also create a mutable map using mutable map of. Now, if you want to change a specific value, you can do this by using the key. So this is the key and this is the value. For example, if I want to change my key, the authorization key, authorization header, I can use HTTP headers, and then use square brackets and pass in our key. In this case, it is authorization, and now I can set this authorization to something else. So now, if you want to print out the HTTP headers, you can do that like so. Let's go ahead and run and see the result. And of course, this is the map. It have a key, value, and so on. So now we have the map printed, we have the key, authorization, and now it's pointing to something else because we changed that right here. Also, we have content type, key, and the value is application JSON. And finally, we have the user local, which is US in this case, and you can iterate through them easily. For example, you can take the HTTP headers map and then use the for each for loop, and now you would have two things. We have the key for each element and we have the value for each element too. Then you can print ln these values, and I can say, for example, value for key. We are now accessing the value of this key variable. We are concatenated or injected inside this string is value. So now let's run and we should see the key and the value printed out in the same line and each header. So the value for the key authorization is something else, and the value for the key content type is application JSON, and that's it. So let's talk about Lambda expressions, or simply lambdas. Are essentially small chunks of code that can be passed to other functions. So you don't need to declare a function either. You can effectively just pass a block of code, and you will see that in a moment, directly as a function parameter. Let's go ahead and create a lambda function that takes two integer parameters, x and y, and its body consists of a single expression that will sum two numbers. So for example, I have sum, and let's go ahead and create our lambda expression. It's always surrounded with curly braces, and it would have two parameters, integer x and also integer y, and then we can use this arrow to return the result, which is just simply x plus y. So now we have a lambda expression, have two parameters x and y, and it will return the sum of those two numbers. We stored the lambda inside this variable right here, and you can treat it like a normal function and call it with an argument. So for example, I want to print the sum. As you can see, just like a normal function, I can print 3 and 6, and then go ahead and run the application, and we should see the result, which is 9 in this case, printed out just like a normal function. It have two parameters, x and y, and we return the result, which is the sum of those two numbers. And Kotlin uses lambda expressions a lot with collections. So for example, if I have a list and I have it as a list of example Java, Kotlin, and Python, I can use for each, and this is the lambda expression of the for each. As you can see, this is a lambda, and you can execute a block of code and print it out. So this is also a lambda function, and it's used a lot in collections. So let's talk about high order functions. And a high order function is just a function that takes another function as an argument or returns 1. So in order to declare a function that takes a lambda as an argument, you need to know how to declare the type of the corresponding parameter. We already created a lambda without declaring the type. This is a lambda, and we didn't declare any type, and we relied on Kotlin's type inference, which will figure out the return type or the type directly. But we can explicitly declare this type of lambda, and we can put the function parameter types in curly braces followed by an arrow and then the return type. So let's go ahead and just modify our lambda here. So instead of just letting the compiler figure out the return type, we can do that directly. It's a sum, and then you use colon operator, and it will have two parameters of type integer, and the return type can be indicated with an arrow, and it will return an integer. So now we defined a lambda with the type. Now let's create a simple high order function that takes a function called operation that has two integer parameters and return type of integer. So let's go ahead and create a high order function here. Fun. And let's call it 2 and 3. And it will take a parameter called operation. And this operation is just a function that takes two parameters of type integer and return an integer 2. So it will match the type we declared right here. Let's go ahead and write the body of it. And the body is just simple. We will just get the result by calling the function. So this is a high order function. It will take a function as a parameter. We execute that parameter function, and then we return the result. We can print it like so, and the result is result. So let's go ahead and try to do that here. Let's call 2 and 3. And as you can see, we passed some directly. Let's run the application, and we should see the result is 5 printed out. As you can see, the result is 5. Just to wrap things, a high order function is just a function that takes another function as a parameter. We declared our function right here by specifying it has two parameters with type integer, and it will return an integer 2. And this is exactly will match what we have right here. And this is the name of the function. You can name it anything. And finally, you will pass this function. And as call functions execute a block of code within the context of an object. Kotlin have 5 scope functions: let, run, with, apply, and also. And basically these functions do the same thing, execute a block of code on an object. But the difference is how this object becomes available inside the block and what is the result of the whole expression. So let's go ahead and talk about the first scope function, which is let. So in let, as a context object is available with an argument, it and usually let are applied to an instance of a class and can be used to invoke one or more functions on the result of the chain. So for example, let's go ahead and create a new Kotlin file or class and call it animal. And this class, let's make it a data class just to save time. And this data class will have the name of the animal of type string and also the age of the animal of type integer. So we have two parameters. So let's go ahead and create an instance of this animal, call it animal, and let's name it puppy, and the age is 3. So now we have this animal. Let's go ahead and use let function inside it. So with let function, you can use animal dot let, and as you can see, it will execute a lambda expression block. Let's go ahead and use it, and the instance will be available as an argument called it, as you can tell from here, and then you can execute functions for this animal or access its properties. So for example, if I want to print the animal name, I can print it using it dot name. And of course, if you want to execute a function or the on the animal, you can that too. Let's go to the animal class and let's just add a function right here. Move, for example, any animal can move, and the function will be empty. Just to demonstrate this, you can directly then use it dot move and it will execute a function in this object. And let will is usually used for executing blocks of code with not null values. So for example, if this animal was null, if it's a nullable variable like so, I can use let here after the safe call operator, and then I can use it to access the object and use it. Next, let's talk about with. With is not an extension function like the other functions, and the context object is passed an argument, but inside the lambda, it's available as a receiver using this. Using with is simply like using with this object, do the following. Let's go ahead and see an example. I have a list of numbers right here, mutable list of numbers 1 2 3. That's good. And now I can use with. It is not an extension function. I cannot, like for example, do number dot with like so, okay? But you will use with like so, and then pass in the list, and then finally we have our lambda expression, and we can use it like so. With this function we want to do the following. For example, let's go ahead and use print ln. For example, let's print it contains size. As you can see, we can access the list attributes directly because it's available as this right here. We don't need to do this dot or it dot in this case. So for example, it contains this size of an element. And now if we executed the code, we can print it. We can see that it will print it contains 3 elements. Next, let's talk about run. And in this function, the context object is available as the receiver this, and the return value is a result. A run is useful when your lambda contains both the object initialization and computation to the return value. So for example, if I have a list of numbers like so, for example, mutable list of numbers 1 2 3, and then I can use numbers dot run right here, and I have the context available as context object available as this, and I can use it, for example, to add a new number like 4, and then add 5 right here, and then I need to count those elements. So I'm going to count those elements, and finally we can store the result right here, the count of the numbers, and I can print the count directly. So we have count right here. Let's go ahead and run. So we use run to add 2 values and then calculate the count. Now as you can see, we have 5 because the run function will return the result as a value, which is the last result. So the last line in the run function will be the return type, which is the return value of the count. As you can see, count will return an integer, so the lambda will return an integer. Next, let's talk about apply. And in this function, the context object is available as the receiver this, and return type is object is self. And we use apply for object configuration, such as we want to apply a following operations on an object or assignment. I will create this animal and then I want it to apply a function inside it directly after it's initialized. For example, I can call move. So now I created the object and then applied some function which is move, and this is very useful and it's used a lot in Android. And the context object is available as an argument, and the return type is the object itself, and also is good for performing some actions that take context object as an argument. So for example, you can use it like this. Do this and also do the following with an object. So for example, let's create a numbers again and call it mutable list of numbers. And then using numbers, I can use also. With also, we can print before adding new one. Let's go ahead and print the list. And as you can see, it's available as it. I can do $sign it. And after that, it will return a reference to the numbers. And then I can call add and add in the number 4. So if we printed the numbers after that, you will notice that the numbers, this statement will be executed and 4 will be added, and finally we will print it. So the list before adding a new one is 1, 2, 3, 4, and after that we printed those lines